that copper crystallized into FCC unit cell. So let's first draw FCC. This is my FCC with a cell edge of 3.608 10 to the power minus 8 centimeter. So this length is given 3.608 into 10 to the power minus 8 centimeter. In another experiment, copper is determined to have density is 8.92 gram per centimeter cube. So here you have to calculate the atomic mass of the copper. Since it is FCC, we know that Z is what? 4. There are 4 atoms in this cell. Correct? So the formula we know that with the formula we had was D is equal to Z into molecular mass by Na divided by A cube. What did you find M? The same formula we'll rewrite, we'll get M is nothing but D into Na into A cube by Z. Correct? Let's put the value. Density is what? 8.92 gram per centimeter cube. 8.92 gram per centimeter cube. Please put the units also. Into Na. Na we know that regular number 6.022 into 10 to the power 23 atoms per mole. Correct? Into A cube. A is what? Length. This is given 3.608 into 10 to the power minus 8 cube, and the unit will be centimeter cube. Divide by, the whole thing is divided by Z, and Z is just 4 without any units. This centimeter cube will cancel, right? And yeah. So with this, when you solve this, you get 63.1. Unit will be gram or yeah, and this is atoms, actually 4 atoms, so it cancels. Gram per mole. So this is nothing but my atomic mass. So atomic mass is nothing but 63.1, and that is my answer. Just application of the formula. We'll take one more example now. Silver forms CCP lattice and X-ray. So first form, let's try to create the CCP lattice. An X-ray studies of its crystal shows that the edge of its length is 408.6 picometer. Calculate the density. Again, since it is CCP, Z is nothing but 4. Correct. Now I have to find density of silver. To density, we have this formula: density is equal to Zm by A cube into Na. So let's see if I have all the values. Z I know 4. M is molar mass. We know the atomic mass is 107.9. A is length. We have this length. Na is something we know, right? So let's find the value. Z is 4. Okay, 4. M is the molar mass. It is 107.9 gram per mole. Please write the units properly, else you may get confused. By A cube. What is A cube? A cube is A is 408.6 picometer. So 408.6 picometer I'll convert into centimeter into 10 to the power minus 10 centimeter cube. Why? Because I want density in gram per centimeter cube. This is gram. Na. What is Na? Na is nothing but 6.022 10 to the power minus 10 to the power 23 atoms per mole, I think. Atoms per mole. And this is 4 atoms actually. Cancel. Mole also cancel. So with this, you solve this, you give 10.5 gram per centimeter cube, and that is my answer. Correct. Let's take one more numerical. What is the two-dimensional coordination number of a molecule in square closed packed layer? So let's draw the square closed packed layer. Asked for two-dimensional coordination number. We have seen that this, for example, this atom is linked to 1, 2, 3, 4 other atoms. So coordination number will be 4. Pretty easy. Since it is two-dimensional, it's pretty easy. A compound forms hexagonal closed packed structure. This is my hexagonal closed packed structure. What is the total number of voids in 0.5 mole of it? And how many of these are tetrahedral voids? See, we know that n molecules will get n octahedral void and 2n tetrahedral void. This is something we know. So if we can just find the number of molecules, we can easily find the number of octahedrals and tetrahedral voids. It says that it is 0.5 mole. So 0.5 mole means what? 0.5 mole means 0.5 into 6.022 into 10 to the power 23 molecules or atoms. Right? Number of atoms. And you can take any of these, doesn't matter. This is nothing but 3.011 into 10 to the power 23 atoms. So we have these many atoms. Since we have these many atoms, number of tetrahedral voids is what? Double of this. That is 6.022 into 10 to the power 23. Double of this. Number of octahedral voids similar to this, that is nothing but 0.0011 into 10 to the power 23. If you add these, you get what? 9.03 into 10 to the power 23 voids. Correct. So the question says a compound is formed by two elements M and N. The N forms CCP. So let's form CCP. N forms the CCP. And atoms of M occupy somewhere in the void. 1/3 of tetrahedral voids. What is the formula of compound? See, if N is equal to X, let's suppose, M will be what? 1/3 of tetrahedral voids. And tetrahedral void is what? 2x. We have seen that tetrahedral void is double of the number of atoms. Remember 1/3 into 2x. That is the value of M. Because M is nothing but 1/3 of tetrahedral voids. It is 2/3x. Find the M is to N ratio. Nothing but M is 2/3x. Is 2x. That is something but 2:3. That means M2 N3 is the formula. Correct. Which of the following lattice has the highest packing efficiency? Simple cube, body centered, and hexagon. So we have seen that simple cube has a packing efficiency of 52.4% almost. Body centered almost 68%. We have seen this numerical. And hexagonal 74%. This is the max. Hexagonal closed pack has the maximum efficiency. Element with molar mass of 2.7 10 to the power minus 20 kg per mole forms a cubic unit cell with edge length of 405 picometer. Density is this. What is the nature of cubic unit cell? We have to find what is the nature of cubic unit cell, how we can do, we can find the value of Z. Z is 1 simple cube, 2 then it is a body centered, 4 that is the face centered, correct? So we have this formula, density is equal to m Z Na by A cube. I have to find Z. Z is nothing but D Na A cube by m. So let's put the values in the formula now. Z is equal to, D is what? Density is given 2.7 10 to the power 3 kg per meter cube. So everything is in kg units. Let's put that. 2.7 10 to the power 3 kg per meter cube into Na. Na is nothing but minus 6.023 10 to the power 23 atoms per mole. Done. A cube, since this is meter cube, we have to convert this A into meter. 405 picometer is nothing but 405 into 10 to the power minus 12 meter, and we give 4 cube, divide by m. M is nothing but molar mass. So molar mass, if you see, it is coming out, it has to be in the form kg now, correct? Because this is kg, kg and kg has to cut. So molar mass is given in the form of kg only, 2.7 10 to minus 2 kg per mole. Mole cancel, kg cancels, meter cube cancels. So with this you solve, you get 384, or actually 384 into 10 to the power minus 2. That is almost equal to 4. That is nothing but 3.84. Almost equal to 4. Since it's almost equal to 4, it is CCP. Correct? Please take care of the units. You have to convert this picometer into meter, else it won't cancel. Question is, what is coordination number? Coordination number is nothing but the nearest number of neighbors. Is sum of the nearest number of neighbors is called coordination number. And what is the coordination number in case of these cubic closed packed structure and body centered? This is my cubic closed pack, this is body centered. So we know that in cubic closed packed structure, this one we have coordination number 12, and here we have coordination number 8. This you can see here. You take this atom, 1 2 3 4 5 6 7 8 are touched to it actually, and you take this atom, if you see, then you have 1 2 3 4 5 here, and then not each of these are touching actually, but if you see, this has 12 coordination number. See, the way it is, let's take this atom, star atom. So it is in touch with 1 2 3 4 here and 1 2 3 4 here. This is 4, this is 4, correct? 4 on the corners, 4 on this. Now there will be one more unit cell on top of this, exactly same as this. If you take this part and put it here, because this will be complete atom, right? Correct? Now this will also be in touch with the next 4 face centered here, correct? Because see, there will be one more cell above it. Exactly, you copy this part, whole part, this part, and paste it on top of this and visualize it, because this atom will merge on this, and you'll see it is touching 4 more here, correct? So plus 4 plus 4 plus 4, that is 12. So it has coordination number of 12. The question is, how will you determine atomic mass of a known metal if density and dimension is given? Pretty easy, we have derived this formula, density is equal to Zm Na into Aq. So to find atomic mass, density is given, dimension of the unit cell is given, and Na is something we know, it's a constant number, so we can easily find the mole mass.